Hello, this is Dr. Hanaa Assil, and today we're doing some questions and answers on energetics. Energetics, in this case, is mainly for the IGCSE um, syllabus. The first question here says, find the enthalpy change. Again, I'm going to remind you that enthalpy change is the delta H for this reaction when excess magnesium is added to 100 centimeter cubed of 2 mole per decimeter cubed copper sulfate. The temperature rises from 20 to 65. First of all, we said when we have a reaction like this and I want to get delta H, then I use the equations that say Q is equal to mc delta T, and then delta H divided by is Q divided by N. So the first thing we're going to do is Q. Reminding you again, Q is the quantity of energy. How do we get it? mc delta T. M is the mass of the solution. Where did I get the mass of the solution? You remember that a solution is mostly water. The density of water is 1. That means the mass of water or the mass of a solution is the same as its volume. So if he says I used 100 centimeter cubed of copper sulfate solution, that is my mass. That's 100 grams. Times C, you should know that C is 4.18, times delta T, which is the difference in temperature. So we have, it went from 20 to 65. The difference between them is what we call delta T. Now, remember that the Q that comes out from this equation is in joules. So usually it's a big number, and we divide it by 1,000 to get it in kilojoules. Then he wants the enthalpy change. And you should realize that delta H is Q over N. So we need to get N, which is the number of moles. Now, how do we get number of moles in this case? Remember, if he gives me a mass of something, it's mass over molecular mass. But here he gives me volume and concentration. So he says I have a volume of 100 centimeter cubed, concentration of 2 mole per decimeter cubed. Then I use the equation that says number of moles is concentration times volume. Remember that the one in mole per decimeter cubed, that's the concentration. So I have a concentration of 2.00 times the volume. Remember that to put the volume into this equation, it has to be in decimeter cubed. So if he gives it to me in centimeter cubed, I have to divide it by 1,000 before I put it into this equation. And this means that I have 0.2 moles. The delta H is the Q that we got over the number of moles. That gives me a number. Now, I want you to remember that delta H must have a sign. So 18.81 divided by 0.2 is 94.05, no problem. But it must have a sign. Should I put a positive or a negative? How did I know that I'm supposed to put a negative? Well, I looked at the question and he said there was a temperature rise. It went from 20 to 65. And we said when the temperature of reaction rises, does that mean that it is exothermic or endothermic? If the temperature rises, it is exothermic, and that means the delta H must be negative. Okay? The next question says a student uses this apparatus to find the heat energy released from combustion of heptanol. So he's burning heptanol using the heat to heat up a metal can containing water. And he says the student burns 0.75 grams of heptanol and calculates Q to be 19 kilojoules. So he already calculated Q and he found that it was 19 kilojoules. Now use this information to calculate the molar enthalpy change. So basically he's giving me Q and he's saying get delta H. Well, I should know that delta H is Q over N. So the first thing that I need to do is get N. Now how am I going to get the number of moles of heptanol? Well, he gives me that I have 0.75 grams. So number of moles in this case is mass over molecular mass. You divide it by the molecular mass of heptanol, which he already gives me. And that gives me the number of moles. And delta H is the Q over the number of moles. So I get a number. Again, I need a sign. Should I put positive or negative for the delta H? You have to remember that burning of anything is an exothermic reaction. It releases heat that heats up the water. So the delta H for any combustion reaction must be a negative number or an exothermic reaction. Another question says this was they were doing titration, and they said they put 25 centimeter cubed of potassium hydroxide with a certain temperature, and then they added acid from a burette that was about 25 centimeter cubed and at a certain temperature, and he's saying calculate Q. Again, we said Q is mc delta T. What is M? Remember, we said M is the mass of the solution. What is the mass of the solution in this reaction? He put 25 of potassium hydroxide plus 25 of acid, so the mass of the solution is the total. That's 50 grams. The difference in temperature is the difference between 35 and 16, and the Q would be the mc delta T, so the mass, total mass of the solution. Remember that M is the mass of the solution, so if you put 25 on 25, the total is 50, times the 4.18, which is the C, times the difference in temperature. Remember again, Q, you don't put a sign for Q. You put a sign only for delta H. Okay, this question says he used this apparatus to find the increase in temperature of water when methanol is burned. So he has methanol in a spirit burner, and he's using it to heat a certain amount of water. He weighed the mass of the burner and methanol before combustion, and then he weighed the mass after combustion, and we have a certain mass of water, an initial temperature, and a final temperature. And he's saying calculate what is Q. Well, Q is mc delta T. What is M? M is the mass of water, not the mass of the methanol, the mass of the solution that you're heating, the mass of water. So in this case, the mass of the water is the 125 times 4.2 times the difference in temperature. Again, the number that comes out is in joules. Then he says the relative molecular mass of methanol is 32. Now use this information and your value for Q to calculate delta H. We know that delta H is Q over N. So I need to get N. Now how do I get N? N will, in this case, would be the mass over the molecular mass. He has a certain mass of burner and methanol before burning, a mass of burner and methanol after burning. The difference between them is the amount of methanol that actually burned. So the mass of methanol burned is the difference between these two masses. That is the mass. I use that to get number of moles. Number of moles of methanol will be mass over molecular mass. And from this, I can say that delta H is Q over N. Again, this is a combustion reaction. So this is an exothermic reaction, and the delta H has to have a negative sign. Okay, this question says the equation for a reaction that occurs in the manufacture of nitric acid is this. State the meaning of this symbol and that symbol. Now, that first symbol, you should remember, means that the reaction is reversible. Now, the delta H, please do not say that this is delta H. Don't try D-E-L-T-A-H. This is not, we read it as delta H, but what does it indicate? It indicates enthalpy change or heat change. If the word enthalpy is too difficult, you can write heat change. What does the negative sign of delta H indicate? Remember, if delta H is negative, that indicates that the reaction is exothermic. So he's telling me that this reaction is exothermic. Now write the energy level diagram. Remember, how do we write the energy level diagram? We said the reactants have a certain amount of energy. Now, if this is exothermic, that means the reactants lost heat or they gave out heat to the environment, and that means the product in any exothermic reaction has lower energy than the reactants, and the difference between the reactants and the products, that is what we call delta H. So the difference going down from ammonia plus oxygen to give NO plus 6H2O, that is the value of delta H. Again, remember, don't just write reactants and products. If he gives me a specific equation, I have to write the specific reactants that I have in this equation. So I have 4NH3 plus 5O2, and my products are 4NO plus 6H2O. Don't just write reactants and products. Okay, this next question says a student investigates the reactions between acids and alkalis. He uses this apparatus to measure the temperature change between dilute hydrochloric acid and sodium hydroxide. This is his method. He adds 25 centimeter cubed of dilute hydrochloric acid to the polystyrene cup, and he adds some aqueous sodium hydroxide, stirs the mixture, records the maximum temperature, and he repeats the experiment using different volumes of sodium hydroxide. The first question says, what is the advantage of using a polystyrene cup rather than a glass beaker? Remember, any reaction in which I need to measure the temperature, it should be done in a polystyrene cup, not a glass beaker. This is because the polystyrene is an insulator, so there will be less loss of heat to the environment. Then he gives me here a table and he says plot these results on the grid, and please pay attention to what he says. So here he's saying draw a straight line of best fit through the first 4 points and another straight line of best fit through the last 3 points. Extend both lines so that they cross each other. So when you plot the points, well, you know that you should plot them in small x's. Can you see the small x's? Don't just go ahead and make it into a curve. You have to check. What did he say? We have to draw 2 straight lines. Should cross at some point. Okay, the question says for the point where the lines cross, write down the temperature and the volume of sodium hydroxide. So at the point where they cross, look at the temperature. So the temperature here is about 24.4 according to this graph. And we go down to get the volume of sodium hydroxide, which is 17.0. It's very important to plot graphs properly and to get the information from them correctly. Then he says in a similar experiment using a different acid and alkali, the student records these results. So he says he used the volume of sulfuric acid is 25. Volume of potassium hydroxide is 22.7. This is the initial temperature and this is the final temperature. And he says calculate the heat energy. Again, the heat energy is Q. It's equal to mass times 4.2 times temperature. Now, mass of what? We said mass of solution. So what is the total mass of the solution? He put 25 sulfuric and 22.7 potassium hydroxide. That means the total mass of the solution is 47.7. Again, I'm reminding you, mass is the same as volume for a solution because the density of water is 1. Then I can use this mass and the temperature change. So the temperature change is the difference between them to get Q, and what comes out of Q is in joules. So if you want it in kilojoules, you will have to divide by 1,000. This question says we have butane. It's a gas at room temperature and pressure, and the equation for the combustion of butane is this. Now state what the symbol delta H represents. Again, remember that delta H is enthalpy change or heat change. Then he said the mass of water heated is 200 grams. The mass of butane used is 0.725, and this is the initial temperature and this is the final temperature. Now use this to calculate the heat produced. So again, heat produced is Q. We said this is equal to mc delta T. The mass here is 200. The 4.2 is the specific heat capacity, and the temperature rises the difference between the two temperatures, and what comes out is in joules. Then he says a student uses the value to calculate delta H, and he calculates it as a certain number, and he says the data book value is something else. Now remember, when we do any reaction in the lab, to get delta H, for example, the delta H that we get from the experiment is usually a lower number than what it should get. First of all, he's asking what is the significance of the negative sign. We said if something has a negative delta H, that means the reaction is exothermic. Then he says the student notices that at the end of the experiment, the bottom of the beaker is covered in black soot. If you have not done organic, then you should know that when we burn a fuel like butane or an organic compound like butane, sometimes there is not enough oxygen, so we have incomplete combustion, and that gives out things like carbon, which is a black soot, or carbon monoxide, which is a toxic gas. So whenever he says you get a black soot when you burn a fuel, or you get carbon monoxide when you burn a fuel, this is due to incomplete combustion of butane. That means the butane burned using a very small amount of oxygen, or there was not enough oxygen. Then he says, okay, explain how the formation of the soot accounts for the difference between the value of delta H from the experiment and the value of delta H in the data book. So how does this account that my value for delta H is different from what it should be? This means that less heat is produced. If there is incomplete combustion, there is less heat produced, so there is less rise in temperature. So one reason for the lower value of delta H is the fact that there was incomplete combustion, so there is less heat produced. Now, suggest one other reason why the values are different. Remember that some of the heat is usually lost to the surroundings. When we burn the butane, not all of the heat is used to heat up the water. Some of it is lost to the surroundings, so we have less rise in temperature. Okay, this one is another question. He says a manufacturer investigates some reactions that produce hydrogen, and the table shows 3 reversible reactions. So the first question says, for reaction 1, predict whether the pressure should be low or high to give the greatest yield of products. So we want the reaction to go forward. Should I increase the pressure or decrease the pressure? Remember, we said increasing pressure goes to less molecules. Decreasing pressure goes to more molecules. If I want to go forward, am I trying to make more molecules or less molecules? Well, let's see. If I'm going forward, I make 1 of CO2 and 4 of hydrogen, so that's 5. If I go backward, I make 1 methane and 2 water, so that's 3. So that means going forward, I am making more molecules. More molecules means I should use lower pressure. Lower pressure goes to the side with more molecules. This is the reason, because the forward reaction gives more molecules. Then he says, for reaction 1 again, predict whether the temperature should be low or high to give the greatest yield. Well, let us see. We said if we're changing the temperature, I have to look at whether the reaction is exo or endo. Now, the forward reaction, in order for it to give me more CO2 and 4H2, is this exo or endo? He tells me that the delta H from the table up there, the delta H for that first reaction is plus 165. That means that the forward is what? The forward is endo. So should I use higher temperature or lower temperature? Remember, we said high temperature goes endo. Low temperature goes exo. So I want to go endo, I want to go forward, and that's endo. Then I should use a higher temperature because the forward reaction is endothermic. Another question says, when hydrogen burns in oxygen, heat energy is transferred to the surroundings. State the name given to a reaction in which heat energy is transferred to the surroundings. We said any reaction that gives out heat, this is called an exothermic reaction. Write an equation to represent the reaction that takes place when hydrogen burns in oxygen. Well, that's easy. Hydrogen plus oxygen would give water, and then you need to balance. Again, a chemical equation is a symbol that is balanced, not a word. If he wants you to write word equation, he will say write a word equation. Otherwise, it is a symbol and it has to be balanced. Okay. This one says a student does some experiments to find heat energy released when natural gas burns, and he's telling me that the volume of gas burned is this and the temperature rise is this. Now calculate the amount in moles of methane burned in experiment 1. So he wants the number of moles of methane. From this information, how do I get number of moles of methane? Well, methane is a gas, and he's giving me the volume of the gas. So the number of moles is what? Volume over 24. And the volume has to be in decimeter cubed. He's giving it in centimeter cubed. I have to divide it by 1,000 before I put it into that equation. So it's 1.45 divided by 24, and this gives me a certain number of moles for methane. Then he says the quantity of heat energy released is this. So he's already given me Q. So he's given me Q, and I already calculated number of moles, and he's saying calculate the molar enthalpy change. So he wants you to calculate the delta H. Again, the delta H is Q over N. He's giving me the Q, and I calculated the number of moles, so this comes out, and this is in joules. Why did I put a negative sign? Again, combustion of anything, burning of anything is an exothermic reaction, so that means that my delta H must be a negative number. Then he's saying in another experiment, the temperature rise is 41.2. So he's repeating that previous experiment with a certain temperature rise of 41.2. Now, the heat energy is volume of water times 4.2 times the temperature. What was the volume of water again? Let's just go back. The volume of water in the beaker was 200 centimeter cubed. So that means I have 200 grams times the 4.2 times the temperature change that he gives me. Again, the Q comes out in joules. Then he says the student uses the results from another experiment to calculate the molar enthalpy change, and she compares her value with the value in a data book. Again, her value is lower than the data book. So instead of getting 510, the data book says it should be 890, which is the best explanation for this difference between the two values. Again, why is it that my delta H will be different from the data book? We said this is because some of the heat is lost to the environment, or not all of the heat is transferred to the water. Then this is the other method of getting delta H. We said we either get delta H from Q equals MC delta T, and then the delta H is Q over N, or by using bond energies and determining the amount of energy needed to break the bonds in reactants and the amount of energy released in the products, and then we calculate delta H. So here he gives me an equation, and he gives the bond energies for each type of bond. Again, remember, we're looking at the bonds. So he's saying every CH bond will need 412 to be broken. So I have how many CH bonds in the reactant? I have 4 CH bonds. So that means 4 times 412. Plus I have 2 O double bond O. And he's telling me from the table that each O double bond O needs 496. I have 2 of them, so I multiply by 2. That comes out to be a certain number. So this is the amount of energy that I need to add in order to break the bonds in reactants. Then he says use the values to calculate the energy given out when bonds in the products are formed. Well, what bonds do we have in the product? I have C double bond O. Each C double bond O will release 743. I have how many of them? I have 2 of them. I have one on this side of the CO and one on the other side. So I have 2 CO bonds. Then I have each OH is 463. Now, how many OH bonds do I have? Well, I have 2 water, and each water has 2 OH bonds. So I have a total of 4 OH bonds. Remember that when bonds are formed in the products, they release energy. So this is a minus. Now, add them all up. The reactants minus the products comes out to be a negative sign, and that means our negative number, and that means that overall this reaction is exothermic. Another type of this reaction, we have again an equation, and he's telling me calculate the enthalpy change. So let's look at the bonds. I have CH bonds. Each CH will need 412. How many CH bonds do I have? I have 5 CH bonds. Can you see that? That means 412 times 5. Plus, what other bonds do I have in the reactants before the arrow? I have a C single bond C. So that needs 348. I have a CO bond. That needs 360. I have an OH bond. That needs 463. So the total energy needed to break the bonds in the reactants is 3,231. Then we look at the products. Which bonds did we form in the products? Well, I have CH bonds. I have 4 of them. And then I have one C double bond C, which is a 612, plus I have 2 OH bonds. So that comes out to be this number. Reactants minus products will give the overall delta H. In this case, it's a positive number, and that means it is an endothermic reaction. This is another question. It says a student uses this apparatus to investigate the temperature change that occurs when potassium hydroxide is dissolved in water, and he gives me the student's value and the data book value. And again, he's saying suggest 2 reasons why the student's value differs from the data book value. Again, remember, some of the heat was lost to the surroundings. In this case, I cannot say incomplete combustion because I'm not burning anything. So if I were using like the question that was saying I was burning butane, so we said one of the reasons would be incomplete combustion. But here we don't have anything burning, so the other reason for the different delta H would be what I started with was not pure. So the potassium hydroxide that I started with was impure. Here he's saying in one experiment, pentane was used as the flammable liquid. The calculated heat energy was this. In the experiment, the mass of pentane burned was this, the relative molecular mass of pentane. So he already gives me the MR of pentane. And he's saying calculate the molar enthalpy change. So he already gives me Q, and he wants delta H. And you know that delta H is Q over N. So I need to get N. How do I get N of pentane? I have mass, a molecular mass, so number of moles is mass over molecular mass. Now to get delta H, I just divide the value he gives me for Q over the number of moles. The answer has to be in a negative sign because again, this is burning of pentane, so this is an exothermic reaction. Ethanol and methanol can both be used as fuels. A student uses this apparatus to find out how much energy is produced when 1 mole of ethanol and 1 mole of methanol are burnt. So he has ethanol and he gives me the formula mass of ethanol. So he already calculated the MR of ethanol, and he's telling me that the energy given out by 1 gram is this. Now, by the whole MR, this is 46 grams. So that means 46 grams will give how much? We multiply these numbers and he got 961. Then he's saying do the same for methanol. Now calculate the energy given out by 1 mole of methanol. Well, we need to get the MR of methanol first. So the MR of methanol is 32. And he's saying I have 32 grams. Now the energy given out by each gram is 15.6. So the total is 499, and that is the energy given out by 1 mole of the fuel. The student uses the same burner and copper can in each experiment. So he did it once with ethanol in the burner and once with methanol in the burner. State 2 factors that the student should keep the same in each experiment. So in this case, remember that every time I repeat it, I should use the same volume of water. Another thing would be keep the same distance of flame from the can. This question says zinc phosphide reacts with water to form zinc hydroxide and phosphine, and he's saying the factory was evacuated because phosphine can burst into flames immediately when it comes into contact with oxygen. What does this suggest about the activation energy? Now, if something will spontaneously burst into flames, that means it's a very fast reaction. And what does that tell you about the activation energy? Remember, if a reaction is very fast, that means its activation energy is low. Do you remember what is the meaning of activation energy? Activation energy is the minimum amount of energy needed to start a reaction. So if a reaction is fast, that means it needs just a small amount of energy to start. So the activation energy is low. If a reaction is very slow, that means it needs a lot of activation energy in order to start. So if the activation energy is high, the reaction is very slow. Now, is the reaction between phosphine and oxygen endothermic or exothermic? Well, what did he say? He says phosphine will burst into flames. Burst into flames means it will burn. Well, if it burns, then it is an exothermic reaction. This question says he put 35 centimeter cubed of 1 mole per decimeter cubed of citric acid into the polystyrene cup, recorded the initial temperature, and then he added 7 grams of sodium hydrogen carbonate and he recorded the lowest temperature. So he's given me temperatures. Initial was 21 and the final was 4.1. He's first of all asking us to calculate Q. Again, what is Q? Q is mc delta T. Well, what is delta T? Delta T is the difference in temperatures. What was M? Remember that he said, let's go back again just for a minute. He said we put 35 centimeter cubed of citric acid. So that is the mass of my solution. 35 grams times C is 4.18 times the change in temperature. So this gives me a value in joules. Then he says, calculate the enthalpy change for the reaction. Again, how do we calculate enthalpy change? We said the enthalpy change is the Q over N. So we need to get N. Well, how do we get N? He already told me that we have the concentration is 1 and the volume was 35 centimeter cubed. We said before we put it into this equation, we have to divide by 1,000. So this is the number of moles that I have. Divide the Q with the number of moles. That comes out to be the delta H. If he wants it in kilojoules, I have to divide it by 1,000. So that is 70.6. But then I need a sign. Again, what would be the sign here? How did I know it's supposed to be positive? Because the initial temperature is 21 and the final temperature is 4. That means the temperature went down and that means it is an endothermic reaction. And that means if he says draw an energy level diagram, the reactants are doing an endothermic reaction. That means the reactants will gain energy. That means the products have higher energy than the reactants. And the difference in energy between the reactants and the products is the delta H that we calculate. Are we all following? Okay. Thank you very much for listening. I hope this chapter is a little bit easier for you. Please keep practicing and thank you for listening.